Bismillah. In this first question we have here 1.83 times by 47. This is a variation of a long multiplication question with a decimal point in it. What I'm going to do first of all is count the number of decimal places in my question. Will become apparent in a bit. We have 1, 2 decimal places in this whole question. Okay, so we say 2 decimal places in the question, which will mean we'll have 2 decimal places in my answer. So let's get started. So what we're going to do here is the long multiplication techniques. So we will multiply 1.83 by the first digit on the first line, which is 7, and by the second digit on the second line, we're going to add a 0. We add a 0 because we're not actually multiplying by 4, we're multiplying by 4t. That's what the 0 there has the effect of. Let's get started. So 3 times by 7 is 21. 8 times by 7, that will give you 56, plus 2 is 58. 1 times by 7 is 7, 7 plus the 5. 12. Okay, that's my first digit on the first line. Now what I'm going to do is the second digit on the second line. So all of this times by the 4 now. So 3 times by 4 will give you 12. 8 times by 4 is 32 and 1 is 33. 1 times by 4 is 4. 4 and 3 will give us 7. Don't need this anymore. Right, so the final bit we're going to add them up. 1 add nothing is 1. 8 add 2 is 10. 2 add 3 is 5 and 1 is 6. 1 add 7 is 8. Now, as we made our statement at the beginning of the question, we said that we had 2 decimal places altogether in the question. So we will have 2 decimal places in the answer. Okay, it might look as though I have lined up the decimal points. I haven't. That's according to the method. The method I put them in here. For example, if this question had an extra decimal point here, then we would have a total of 3 decimal places in the question, and the decimal point wouldn't have been here, would have been here. Instead, 1, 2, 3, in that kind of question. So that means the decimal point will go from here to there to there. So I'm not trying to do any type of alignment, I'm trying to follow this simple rule. Okay, thank you very much. This is question number 2. Okay, we're just about getting this into the video. Hopefully this is a nice size for me to actually work on. I'll just read it out to you. Read it from here. The graph shows the distance from the city centre and the monthly rent of each apartment. So we have the monthly rent along here, 100, 200, 300, 400, 500, 600. On the bottom we have 0, 1, 2, 3, 4, 5 and 6 kilometers. This on the bottom one is the distance from the city centre. We just about got it into the scale. I'll try writing here. Okay. Right up here. Distance from city centre in kilometers. Okay, right, hopefully that's all on there. So we have the table shows the distance from the city centre. We have two values to plot. So we have distance, there's 2, and the monthly is 250 to plot onto our scatter graph, and one for 3.1, one for 190. I can't move the table up, otherwise I'll lose the graph. So I'll have to just give those to you verbally. Let's go on. 2 and 250. So the distance is 2 kilometers, which is 2 along the bottom, and the monthly rent is 250. So we'll come along here, come to 250, which is halfway, and put across here. So that's my first point. which is 250. The next point they give us in the examination paper, okay, is 3.1 kilometers on 190 rent. 3.1 is run by here, and 190 is the rent, which is each square going up is worth £10. So 190 is coming along here, and it meets it. Yeah. Okay. What I'm going to do first of all is I'm going to go over the existing points in the black marker, so they stand out a bit more from the projected image. Okay. Right. So these black points were the points already on there. These 2 points are the points I've just put on there according to the question. Okay. Right. So it's going to be 2 kilometers and £250, 3 kilometers and £190 for these 2 points. Now the question says here, after we plot those 2 points, describe the relationship between the distance from the city and the monthly rent. Alright, so let's write down. Now first of all, what would help us before we do that question, we should do a line of best fit. Now, ideally we need a long see-through ruler. I'm going to, if I use my ruler, I'm not going to get the best line. So I'm going to buy. Okay, you need to use your clear ruler to work this one out. Now I'm going to use my ruler over here. So that I'm again looking at an average line between the data. Okay, let's have a look at this line here. Okay. So that's my line. Alright. Okay, this is the line that I've got at the moment. Okay, when you use your clear see-through ruler, you need to put it on there so you position it so you can try to go to as many points as possible, and as many above and as many as below as you can. So it's like an average line going through the data. Right. Don't mind the best of the circumstances I have here with me. Right, now, that's a line of best fit. As we can see, as the distance from the city centre increases, the rent decreases. That is the relationship that we have here. So we need to make that statement. So that's question part B. So question part B, okay, is as the distance from the city centre. So we say as the distance from the city centre increases, as the distance increases, the monthly rent decreases. Okay, now the mark scheme allows you on this particular question to also write a very short answer, which is negative correlation. So in the examination, that's the answer they're looking for, but this one is also acceptable. Okay, so that's part B done. So what we've done first of all, we plotted the 2 points they gave us, done the line of best fit by trying to get an average line going through as many data points as possible and having as many above as below points. So it's like an average line, and using that line we can see that the data is going in a negative correlation, which I've explained in detail here. So as the distance increases, the monthly rent, as the distance from the city centre increases, the rent decreases. That's the key word there. Okay, done. There. Here comes the last part of this particular question, question number 2. It says an apartment is 2.8 kilometers from the city centre. Okay. Find an estimate for the monthly rent for this apartment. So 2.8 kilometers. So 2.8 is here, folks. So what we need to do now, we need to get a line from 2.8 kilometers in the bottom. We need to hit our line of best fit. We need to go across. Okay, we need to get our value. Okay, now this line here is coming from 2.8 kilometers from the bottom. We've gone up, we've hit our line of best fit, we've gone across, and we get our answer here. So that's 200, 210, 220, 230, 240. So the answer, that was part B. Answer to part C is £240. Okay, now for those of you who follow this at home, an answer range of 200 to 260 is allowed for that question according to the mark scheme. It is important to realise this. Not everybody's line of best fit will be in the same, exactly the same point. Not everybody will get the same values I've got here, but you should get a value in between this range for the examiner to give you the full mark. Mine's nice and easily within that range, so that's worth full mark. Okay. Number 3. Paula wants to find out how much money people spend buying CDs. She uses this question on the questionnaire. How much money do you spend buying CDs? 10 to 30, 30 to 50, 50 to 70, or more than 70? Write down 2 things wrong with this question. Okay, let me just keep an eye there. Alright, let me know what's happening. 2 things wrong. So the first thing is, go on, Dishan.
No time frame.
Okay, there's no time frame because buy CDs over a week, in a month, in a year, in your lifetime. So there's no time frame for the question. Okay, now what else do we find?
Money.
Okay, now what's happening about the money? What do we have here?
Overlap.
We have overlap. So overlap, okay, of the values in the response boxes. This is tired. Okay, are we happy with those 2 possibilities? What else could you write down as well? Another possible answer.
No boxes under £10.
No boxes under £10. So they list. So your answer is not exhaustive. It's not an exhaustive list. I mean, it doesn't cover everything. So what happens if you spend less than £10? Where do you put that answer? So that could be a third possible answer that you, or alternative. Okay, next part of the question, which is over here. Paula asked 100 people in a CD store to do her questionnaire. So she's trying to find out about people's spending habits on CDs. And they got the question, the answer, part B says her sample is biased, explain why. So why should she not ask everybody in a CD store? Okay? So what's wrong with that? Give me an answer, please.
It's only at the CD store.
So they are all in the CD store and they are most likely to buy
CDs.
There you go, that's the answer for part B. I'll put part B over here. Some more space over here. So they are all in a CD store. They are all likely to buy CD. See, miss? Check.
Yeah, it's good.
That's the reason why it's biased. They were told. Okay. Complete the table of values for y equals 2x plus 5. This is question number 4a. Okay, so we got here x minus 2 minus 1, 0, 1 and 2. And they already filled some of them in for you. Let's have a look how we do these questions. So, y is equal to 2x plus 5. I'm right over here. And we've got to work it out for which values? For these 3 values. Okay, Mr. Umar, are you happy? Ready with this?
Yes.
Yeah? So So 2 times by x. Right. For the x value, I'm going to use a different color. It's minus 1. Okay. So wherever we see the x, we put a minus 1 in there. Now, quick question. Right, let's have Afira. What is the 2 doing to the x? Is it adding, taking away, multiplying, dividing? What's it doing in this current situation? The 2 is currently doing what?
Times it.
Excellent. Okay, so 2x plus 5 means 2 times by x at 5. So we have to do it now. 2 times by minus 1. 2 times by minus 1 will give us minus 2. Minus 2 at 5. So I owe you £2 and I have £5. So I have £3. Okay, so we've done for minus 1. What I'm going to do, I'm just going to use my finger and get rid of the minus. Because we're going to 1 now. So try 1. So 2 times by 1 will give us 2. And then 2 at this 5 will give us
7.
Okay, lovely. Okay, this is the emphasis. Now, we're going to put 2 in there. So what you need to do is keep on changing the value. You can't obviously rub it out. You've got to rewrite it again and again if you need to. So that 1 is now becoming a 2. Okay, now 2 times by 2 will give us an answer of 4. And 4 at 5 will give us 9. So we have now worked out the 3 missing values. Okay, am I happy with that? Done? What we need to do now, as everybody wrote that, let me write that down into my paper so then I can. So we have here minus 2 is 1. So minus 2 across and up by 1. The next one is minus 1. What's minus 1?
3.
3.
Yeah.
Okay, good. The next one was 0 along the x, is 5 along the y. The next one is 1 along the x and 7 along the y. If you see me put something in the wrong place, please say so. Nicely, sir. You put it in the wrong place. Everything looks right from here, by the way. When I'm doing everything looks right. If you guys see something wrong, tell me. So 2 is going to be 9, is that right?
Yeah.
Now, you should have some points that look like that. Now, what we need to do now, we need to join them up. Okay. When you do your straight line, try not to do it exactly between the points. Try to make it as long as the graph paper allows the graph paper, yeah? So we've got a nice line over there. Now let's have a look what else we want to do. On the grid, draw the graph from minus 2 to 2, which we've done. Questions finished?
Yeah.
That's it, lovely, beautiful. Let's move on to the next question. Have an arithmetic sequence. Okay, arithmetic sequence means that we will be going up in a linear number, so it's going to be the same difference each time. So here are the first 5 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of the sequence. There's lots of different ways of doing this. Okay, now the first one, let's do a bit of labeling first. This first term is called n equals 1, first term. This is the second term, and this is the third term. Okay. First of all, let's try to establish what the difference is. How is the pattern changing? So we're going from 3 to 9. What are we doing?
Plus 6.
Okay, from 9 to 15.
Plus 6.
6, 15, 21.
Plus 6.
So it's plus 6 all the way through. Okay, that's why it's called an arithmetic series. It changes by the same amount each time. So that plus 6 is called what? What we call the plus 6 is called the? It's called the difference. Now, if you want to work out the nth term, what we need to do first of all is work out the 0th term. Okay, now, if you know Zishan where 1 is, where does 0 come relative to 1? Does 0 come after 1 or before 1? Before, isn't it?
1, 2.
What do you reckon that number is going to be? If I'm going that way, I'm adding 6. If I go this way, I'm going to be? Minus 6. So 3 minus 6 will give us?
Minus 3.
Minus 3. Now, if we want to work out the nth term, the nth term is going to be equal to
-2.
the 0th term. Okay, we can write it into quite a few different ways. Just think about the best way to first do this. The difference term by n plus. This is just one style. This is of doing it. There's lots of different ways of doing this particular thing. Now, the nth term mathematically looks like this. The difference, we're going to call it d. So what is the difference at the moment? The difference is it has a value of
6.
and we have to multiply by n is the nth term, so that gives you 6 n. 6 times by n is 6n. Plus the 0th term. What is the 0th term?
-3.
Okay, when you do add -3, it's the same as just saying -3. And we finish that question. So folks, don't think this is the only way to do it. There's lots of different ways of doing this kind of like nth term. Teachers are different. That's just a method that I use. Okay? So there's no messing about. It's the difference times by the n plus the 0th term. It's plus or minus number, so it's just -3. Okay. Ready for the next part? So Ben says, I'll keep in mind the time as well, but you don't run out of video file. Yeah, there's a line on the bottom. Ben says that 150 is the maximum. How much time got left?
6 minutes 23.
Lovely. Okay, Ben says that 150 is in the sequence. Is Ben right? 150. Now, this 150 is not the value that we put into the formula to work out a term. It's actually the answer. So they're asking, is 150 an answer to this pattern? So let's try this, have a look. Let's have a look. So under the UN, what we should put in there is 150. I'm just going to, has everybody copied this dot down here? Yeah? This is the nth term. Okay. And when you write down an expression, okay, for here, what you actually write down here is this. That's an expression. This is an equation because we've got an equal sign in it. So that's me telling you, like, in generally. But according to the examination, that's all you write there and there. Okay? That's what you're doing in class, we're teaching a topic, nth term is equal, right? When they say the word expression, just put down what it is, minus, without put an equal on this in there. So I'm going to get rid of this now, I mean, you don't need this anymore. On the point here, what is the answer? So he said that this is an answer to this pattern. Let's have a look. Okay, let's work out the nth term that would generate his possible answer. Okay, so Umar, I want to work at the value of n, so I want to solve for n, so we start at n. And then we identify the actions. Okay, remember what we've been doing in the previous lesson? So start at n. What's the first thing being done to the n? Times by 6, lovely, that's called the first action. What's the, Hamza, what's the second thing done to the n? -3, that's called the second action. When we solve an equation, we identify the action and we put it and we move the stuff in reverse order. So that means which action goes first? Time by 6 moves first or -3?
-3.
Lovely. -3 goes first. Let's go to that now. Opposite of -3 is?
+3.
Okay, +3. So you have 150 plus 3 will give us an answer of?
153.
I'll just copy down here at the moment. 153. Okay, now, so Mia, what do I move next? So I move the time -3, I have to now move the?
Time by 6.
And opposite of time by 6 is? So we got 153. Does that come here clearly?
Yeah.
Okay, 153 divided by 6. Let's write that out. So 6 goes into 1 how many times? 0, remainder 1. 6 goes into 15 goes how many times? 2. 6 times by 2 is 12, so the remainder is? 3. How many 6s go into 33?
5.
Remainder?
3.
3. Now, in order for 150 to be a part of this sequence, that's the n value by the way, it's 25 and it's a fractions decimal answer.
25.
So n must always be an
Whole number.
integer, whole number. Is this giving us a whole number answer?
No.
No. Okay, so 25 remainder 3 will actually give you, in reality, let's get rid of this for the moment.
25.5.
Put the 3 over here, but then, okay, now, so we have to say, is Ben right? No. Okay? So if Ben isn't right, so if we say no, Ben is okay. Why is he incorrect?
Because it's not a word.
That's right. N must be an integer value. Okay. N is currently 25.5 for Ben's answer of 150. Okay. Alright, are you happy with that? Done that? That's lovely. Keep an eye on that. Okay, here we go. Question number 6, folks. Right. Let's bring it down a bit. Right. Question number 6. Again, I'm going to have to use my paper. Okay, Mr. Rabiz, are you ready?
Yeah.
Okay. Question number 6 says you can use this conversion graph to change between pounds and dollars. So here's the dollars along here and here's the pounds along here. Okay, use the conversion graph to change £5 to dollars. So let's have a look. Where is £5? £5 is here. So what we need to do, we need to go from £5 straight up. And okay. Can everybody have a go at that, please? Right. Okay, done that? Right, what has everybody got? They give you £5 on purpose because £5 according to the graph gives you exactly how many dollars? Exactly? Exactly $8. So we can say that £5 is equal to $8. Okay, from the graph. That's the first part of the question. The second part of the question, I'm not going to move the graph paper at all to read the second part of the question. I'll read it out to you orally and you follow me on the exam paper. So it goes here. Ella has $200 and £800. Okay, let's write some of that information down. So she has $200 and she has £800. Okay, she has to pay a hotel bill for, what's the hotel bill?
$600.
$600. And the question says here, well, she uses the money that she has, she uses this money here to pay for that bill. And the question says, how much money does she have left? So the question is, how much left? And they want the answer in pounds. Okay, so we put the information in the top corner. That should be okay for the moment. Now, common sense question is in a sense like real life question. You've got $200 in your pocket, you're in a hotel. Your bill is $600. You got $200, so you can hand that over. How many dollars you have paid? How many you got left to pay? $400, yeah? So 600 minus the 200 will give you $400. Okay, $400. Okay, folks, that will give us $400. Right, okay, so we got $400 let's pay. Let's work out how many pounds is $400 so then we can take it out from the 800. Now, we have a conversion of here at the moment. £5 is $8 and I want to work out $400. So let's have a look. From $8, let's first of all go to $40. We should be able to do that quite quickly and easily using our times tables knowledge. How do we get from $8 to $40?
60.
By timesing it by 5. Good. But I don't want actually $40. I really want to get towards. So I'm doing it in steps. I want to get to $400. How do we get from $40 to 400? Time by 10. So you broke the question down into two pieces. Okay, so whatever we do on the right hand side, we have to do on the left hand side. Alright, let's have a look at that. Okay, so £5 times by 5 rutaba is 25 pounds. 25 pounds times by 10 is
250 pounds.
250 pounds. So the extra $400 will take out 250 pounds from her. 800 pounds that she's got in cash. 800 pounds. So let's work out how much she's got left. So 800 pounds minus the 250 that she's got left to pay for the bill. So 800 pounds minus 250 gives us an answer of. Don't all shout at once. Okay, 800 times 550. So the question says, how much money does she have left in pounds? And the answer is 550. So we use the conversion graph, the original identity, to work out how much $400 is. And then we're going to minus that from the pounds that she had. And that gives us the answer. Okay, and as far as I can see, that question is worth how many marks, folks? 5 marks for this. Okay, 5 mark question. Okay. Question 7a, nice, straightforward, simplifying algebra. It's a linear expression. There's no squares, no power, nothing crazy in there. It's nice and straightforward stuff. Let's have a look how we do question 7a. Okay, right. Zishan, we have 5x here, and we have another plus x. We have to add like terms. X's with x's, y's with y's. Okay, or we said before, apples with apples and bananas with bananas, yeah? 5x add x will give us a total of?
5x with 6x.
Okay, hang on a second, we've got two answers, 5x squared and 6x. Okay, that's good. Okay, okay, now let's look at the answer we just had. 5x squared and 6x, 5x add x will give us an answer of
6x.
Okay, the reason why it's not 5x squared is because we're not multiplying them. You'll get the answer if you multiply them, you add them. It's like saying 5 xylophones, add another xylophone, gives you 6 xylophones. That's done. Okay, so that's a common mistake in the exam, so I'm glad somebody pulled it out now. Got that over and done with. Next one. Plus 4y and minus 7y. Please make sure when you consider the like terms, you consider the signs that go along with it. Plus and minus now. So if I have plus 4y and I owe 7 yellows, then I will have. So we owe.
Minus 3y.
Okay, are we all happy with that?
Yeah.
Good. Okay, question part B. So we're on question number 7, still part B, go solve. Okay, now, what is the technique for solving any type of question? What we do first of all, we start at?
Expanding the brackets.
Okay, we start at x. Okay, the technique that I've shown you before in previous lessons, when you want to solve something, you start over, you want to make the subject, and since you solve for x, make x the subject. What's being done to the x first of all? The first action is add 2. That's the first thing being done to it. What's the second action?
Times by 7.
Okay, even though the time by 7 looks like it's the first action, it's not. Okay, remember the brackets first, isn't it? So x has been added by 2 and then all of it's been times by 7. So even though it's physically next to it, quite close, it's not actually the first action. So in that case, I have to be a bit careful on this particular one. Now, I want to solve it. Do I need to multiply the brackets? Do I need to multiply the brackets?
Yeah.
You could, but it's not necessary in this question. We'll show you. I will do both ways. Now, when we solve an equation, we do the last action first. Opposite of time by 7 is? So grab the time by 7 here. Get rid of these numbers for the moment now. Opposite time by 7 is divide by 7. 7 divided by 7 is?
1.
Okay, what are we left with now? X add?
2.
What's happened to the brackets? The brackets have evaporated. Gone. Okay? Once the multiplier goes, the brackets go with it as well. So x plus 2 equals 1. Now let's ask Mr. Saf, really hard question now. Really difficult. X add 2 is equal to 1. I need to work out the value of x. So opposite add 2 is?
Minus 2.
MashaAllah. Excellent answer. Beautiful. So 1 minus 2 will give us an answer of?
Minus 1.
Minus 1. And that question is done. I'm doing that way the Zisha want to be doing. Let's just show you that way as well. Okay. This is the other way. The multiply of the brackets way. 7 times by x will give us?
7.
7 times by plus 2 will give us?
14.
Okay, so here we multiply the brackets first of all. First action is times by 7, second action is plus 14. Okay, now opposite of add 14 is?
20.
So 7 minus 14 is?
7.
Minus 7. Okay, now you move the multiply by 7 over. Opposite times by 7 is?
Divide by 7.
So x is equal to?
Minus 5.
Okay, which one looks longer?
That
The second one.
one.
Yeah. Some more steps in it.
Yeah.
Okay, we make more work for ourselves. So that's why I stick that one for the moment. So, next question over here. Trams leave Piccadilly to Eccles every 9 minutes. It is Piccadilly to Didsbury every 12 minutes. A tram to Eccles and a tram to Diddley both leave Piccadilly at 9 AM. At what time will a tram to Eccles and a tram to Diddley next leave Piccadilly at the same time? Okay, this question is, what kind of question is this? It's looking at what? What are we looking at? LC. LC? M. So we start at 9 o'clock. Okay, the first one goes every 9 minutes, so it's going to be 09. And the next one's going to be, after 09 is going to be what? 18, and then after 18 is going to be what? So it's going every 9 minutes. Yeah?
Yeah.
And the other one goes every 12 minutes. Okay, what's the next one after 27? Another one? What's the next line after 27?
86.
Okay, and then let's do the bottom one. Now that was for Eccles. This one for Didsbury. So it goes every 12 minutes. It's 12, 24. At what time will a tram to Eccles and a tram to Didsbury next be picked at the same time? So they're going in different times, but then the time matches at 9:36. So that's the answer to that question, and that question is worth 3 marks.
Is that it?
That's it. Okay, question number 9A, simplify. Let's have Rutaba. Simplify A4 times by A5. You look at the A's, they are both the same, which is good. So if they are the same, then what do we do with indices, Rutaba? We add them. Good. Which gives you what?
8 to the power of 9.
Lovely. Okay. Now, the simplify, this is the next one. I'm going to move it up. I'm going to make it bigger. Oh, that's very nice. Okay. Now, this simplifier's got division in as well. So let's have a look. We have here 45 and 5. What is 45 divided by 5?
9.
So if you divide this by 5 is 1, if you divide this by 5 it will give you 9. Next we have e to the 6. Okay, we got some sleepy students here. All the late night Xbox. Okay, e to the 6 divided by e to the power of 1. What will that give us?
E to the power of 5.
E to the power of 5. Right, next bit. We have f to the 8 divided by f to the 2. And that will give us f to the 6. Why is it f to the 6? Because when you divide them, you minus indices. Okay, so 6 minus 1 is 5. 8 minus 2 is 6. So the final answer for that question will be what?
9 EF. 9 E5.
E5.
F6. That's it.
And that's it for that one. Question 9 to the half, put up here. Write down the value of 9 to the half. First of all, what does the power of a half mean, Hamza? Power of a half means what?
0.5.
Well, you just change into decimal. What does it mean if you have a power of a half?
Square root.
Square root. Okay, n to the power of half means square root. So the square root of 9 will give us an answer of 3. So write down the value of 9 to the power of a half. It is 3. Question number 10. Question number 10. We have here a triangle and some parallel lines as well. This line here is parallel to that line. Okay, CDEF. CDEF is a straight line. AB is parallel to CF. So this is parallel to this bottom part here. and it says DE is equal to AE. So DE is equal to AE is an isosceles triangle. Okay, because work out the size of the angle marked X, which is this one here. You must give reasons for your answer. Right, here we go. In order to work out this angle here, which angle do we need to work out before that? That one. In order to work out that angle, this angle is also going to be the same as? So the y that's here is same as the y there, because this is an isosceles triangle and the angle opposite this line is the same as the angle opposite this line. So these two are both y. Is that right so far? Folks, happy with that? Okay, now, what else do we know? Okay. Right. We also know that the angle sum of a triangle is equal to 180. Okay, right. Let's have a look what else we have here. Can somebody tell me what this rule here is?
Z angle.
Okay, now, I'm glad you said Z angle. Now, what happened in the examination? You wrote down Z angles and are equal or something, you put the answer in there. Would you get any mark for that?
No.
You get 0, because Z angles is like, it's not proper mathematics.
Yeah.
We have to use the word
Alternative.
alternate angles.
Alternate.
Okay?
That's right, alternate.
So we have to say, first of all, this angle here, so you got y, should we call this one Z?
Yeah.
So we've just labeled our diagram. Now, we can say here angle Z. Now we can label it angle Z, or we can actually use it, we can label it according to the letters. So that will be called angle DEA. So let's use the labeling from the DEA. Okay? DEA. Angle DEA mathematically means DEA and it's one in between. That's what it is, okay? So this angle here could be also called EAD.
Can't it be called DAE?
Or it could be called E. I haven't written down where. E should be E. Hang on a second. DAE is right, isn't it? DAE. Okay, DAE, and this one here is going to be EDA. That's labeling according to the labeling of the diagram at the moment. So let's start making some statements now. Let's talk about this angle here. So we can say, what can we say about that? We can say angle. Oh, this is all in there, yeah?
Yeah.
So angle DEA, which is that one here, angle DEA is equal to angle, what's that angle they're called? That's called EAB, which is equal to 38 degrees. Okay, that's the first statement. Now what can we say about this triangle here? So now we can say angle sum of triangle ADE is equal to 180. Okay? And we can also say this triangle is an isosceles triangle. Triangle ADE is isosceles. Therefore, this angle is equal to, yeah, so earlier. Therefore, angle DAE is equal to angle EDA. Okay. Are you happy with that? So let's now make a statement now using that. So these two are going to be both the same. Add that one. What do all these three angles add up to? 180. Okay. So temporarily I'm going to call that Y. That'll be easy for me when I do my calculation. So we can say Y add
38.
is equal to
180.
180. So Y will give us
2y.
2Y. And opposite of add 38 is
1.
So 180 minus 38 will give you 180 minus 30 minus 8. 142. 142 is the value of both of these angles, so one of them will be 71. So we now know that y is equal to, so these angles here are now equal to 71. Okay. Okay, now that we know this one, we can now finally work out x. So what would be the next thing that we say to describe? We said angles at a point. So angles. Now what do students normally say? Angles on a straight line add up to 180. That's wrong. Okay, why is it wrong? Because that line could be this one and this one and that one. That's still on a straight line. This and this and this and this is not equal to 180. You missed out on one small point. And the word is point. Angles at a point on a straight line add up to 180. Yeah? On a straight line. So we write that down. So angles at a point. See this point here. Angles at a point on a straight line equals 180. So now we can make a statement that x add EDA, angle EDA is equal to 180. Now, I've written that statement down. Under the EDA, what angle can we write in there? 71. So we say x add 71 is equal to 180. Now I've got to work out the value of x. So the opposite of add 71 is minus 71. So x will give us a value of 180 minus 71, which will give us 109. 109. Is that all in there? Okay, lovely. I'm sorry folks, unfortunately that is the amount of writing and explanation you need to get the answer. Because the question is, work out the size of angle marked x. You must give reasons for your reasons, yeah? Plural. So first reason, second reason, third calculation, fourth reason, fifth reason, and calculation. So we are explaining each step of the way. So from here we went to here, from here we worked out these two, from these two we worked out that one. So we had to work our way around the question. So it wasn't a straightforward question, we got to do lots of working out. Okay, next question. Question 11. Greg sells car insurance and home insurance. The table shows the cost of these insurances. Cost of car insurance is 200, home insurance 350. Each month Greg earns £530 basic pay. That's his basic. 5% of the cost of all the car insurance he sells, he gets that as a commission. And 10% of all the home insurance he sells. In May, Greg sold 6 car insurances and 4 home insurance. Work out the total amount of money Greg earned in May. Right, let's have a look at this question. So we know that he starts off with how much? £530. Now we've got to work out 5% of the car insurances he sells to work out the commission. Now, how many car insurances did he sell? 6. How much does the car insurance cost? £200, yeah? So what's £200 times by 6?
12,000.
So that'll give you £1,200 worth of car insurance he sold, yeah? He sold 4 home insurances, 4. So he sold 4 of these. So 350 times by 2 is 700, then times that by another 2, that's how you break it down. That'll give us the what Saf has just told us, which is £1,400. Now, so that's how much actually sold. So we have to work out 5% of this one and work out 10% of that one. Let's do that now. Now to work out 5%, so we need 5%. What's one of the easiest way to work out 5%? First of all, we work out 10% and then half it. Lovely, well done. So we're going to work out 10% first. How do we work out 10%? By dividing by 10. So 10% of 1200 will give us an answer of 120. And then to work out 5%, which will be half of that,
60.
which will be 60. That's 5%. Okay, now we've got to work out 10% of the cost of the home insurance. So 10%, to work out 10% we divide it by 10 because it's a tenth. So we knock off a 0, so that gives us 140. 140. 1,400, 10% of 1,400 gives us 140. Okay, so we've got to work out his pay.
Do we just add them up now?
Add them up now, that's right. So he starts with the basic salary of 530. He made an extra 60 quid for selling car insurance and an extra 140 pound for selling house insurance. Okay, somebody's adding numbers wrong, giving me the wrong numbers on the board. Okay, 10, 13, 5, 6, 7, 730 pound. Okay, are we happy with how much Greg has paid to me? Should we move on to the next question?
Yeah.
Right, that question is worth how many marks?
5.
5 marks for this.
5 big marks.
5 marks. That's like Eid coming early. Yeah, it's like a gift. That is so. Come on, what is it? So what? Easy. Okay, question number 12. 5 schools sent some students to a conference. One of the schools sent boys and girls. This school sent 16 boys. The ratio of the number of boys it sent to the number of girls it sent was 1 to 2. So that's the ratio. So the ratio was 1 to 2. Okay, so how many boys did they send them? How many boys did they send?
16.
16. So the boy ratio, so how do you get from 1 to 16?
1 by 16.
So that's how they got that there. So if we time the left by 16, we have to time the...
Right.
So how many girls did they send them?
32.
So how many did they send altogether? Oh, this is really
48.
hard.
48.
So 48 students in total, yeah?
Yeah.
The ratio, okay, we've done the ratio, so there was 1 to 16, that doubles 32. The other 4 schools sent only girls. Each of the 5 schools sent the same number of students. So how many students did each school send?
48.
48. And how many schools were there in total?
5.
5. Work out the total number of students sent to the conference by these 5 schools. So it's going to be 48 times by? 5. Okay, now folks, please make sure you don't feed me wrong answers.
240.
Okay, let's do it nice and slowly. So 8 times by 5 will give us 40. 4 times by 5 is 20. 20 add 4 is 24. So how many kids they send all together? All 5 schools? 240. And that question is worth how many marks?
4.
Are you sure this is high paper? 4 marks for that. So question number 15. Here is a scale drawing of a rectangular garden A, B, C, D. A, B, C, D. Scale is 1 centimeter represents 1 meter. Jane wants to plant a tree in the garden at least 5 meters from point C. So that's my first loci. Now, this is at least 5 meters from point C, which means 5 or more. So what we're going to do first of all, we're going to measure 5 centimeters on this. That's 5 centimeters. So at least 5 meters from point C means 5 or more from C. So I'm going to try my best to do this in one go. So this one, there we go. So it's going to be on this line or more. Okay. Okay, the next part of the loci is nearer to AB than to AD. Here's AB, here's AD. In order for us to be nearer to AB, we need to find out which point is exactly equal between these two. So that is called the angle bisector. So what we need to do now, we need to first of all do a loci, a small curve. Okay, we know this point and this point are equidistant from here. We're going to split that in half. In the middle of those 2 points. This point here. Find out where those 2 points cross. Okay, what we do now, this is the technique for finding out exactly halfway between the 2 points. We use a ruler. We should be able to go through where the curves intersect. Now, this line is equidistant between AD and AB, because nearer to AB than to AD, so you can't be actually part of the line. So we make that dotted. A dotted line. So we know on this side of the line. That we have here is going to be less than 3 meters from DC. Well, DC is this side here, less than 3 meters. We have to go to find out what 3 meters is first of all and do that. So let's get our ruler and our compass. That's 3 centimeters. Now we mark that off. We join the points of that. We make that a dotted line. It says so. This distance here is 3 meters, and less than 3 meters from DC. So it's going to be below this line. We need to find a region that incorporates these arrows going up, incorporates these arrows coming out, incorporates these arrows coming down, and that region is found here, where all those 3 arrows come together. Share the region where, so she can plant a tree in there. Okay. Question number 13. Okay, diagram not accurately drawn, and that's therefore a reason, because students think they're smarty pants in the exam. They get their protractors out and start measuring the angle, and they think they've done anything. MashaAllah, alhamdulillah, they've done it. It was done in 2 seconds. Huh?
Got rubber.
Okay, yes, we got rubber. Okay. Okay, let's read the information on the bottom. I'm going to read it out to you because it's probably at the bottom of the video. The diagram shows a square and 4 regular pentagons. A square. Okay, a square is a regular shape, all sides are the same length, all angles are the same, so very special, it's a regular shape. And it has 4 regular pentagons, and the word regular is used again now. So regular pentagons again, what does that mean? That all the lengths are exactly the same, all the internal angles are the same. So there's not an irregular one. So work out the sides of angle marked as, how many questions is it worth?
3 marks.
3 marks. Okay, right. Now, what do we know? Angles around a point add up to 360. Angles around a point add up to 360. Come on girls, in the back, come on, settle down. Add up to 360. Now, we should have some nice, we should know something straight away. What is the angle in the corner of a square? That angle is 90. Okay, which angle don't we know at the moment? We don't know the angle which is the internal angle of a pentagon. The internal angle of a pentagon. I'll just call that P for the moment, the pentagon one. Okay, what do we know? We know if you go all the way around here, if you go all the way around, that should give us an answer of 360. So let's form a small equation. So we can say the pentagon angle, P the internal angle of pentagon, plus the other internal angle of pentagon, plus the 90 degrees of the square, plus the x that they're given us outside, all of that will add up to 360. Okay, now, if we simplify that down a bit, so that gives you 2p at 90 at x is equal to 360 degrees. Okay, now we need to work out the internal angle of a pentagon. How do we work out the internal angle of a pentagon? What is the easiest way to work out the internal angle of a pentagon? Now, so let's have a look at this pentagon here. Here you go. So I'm going to now extend this line here. Oops. Okay, this here is called the internal angle of pentagon, pentagon internal, and this one is the pentagon external. What do these two angles add up to?
180.
180. Now, how do we work out the external one? Quick way of working the external one is what? So the pentagon external angle is equal to 360 degrees divided by the number of sides. How many sides does a pentagon have? 5. So we can do now. The external angle of the pentagon is equal to 360 divided by 5. Okay. 360 divided by 5 is 72 degrees. So we now know that this outside one is equal to what? 72. If the outside one is 72, then that means the inside one will have to be
72.
No, that's these side of 180.
108.
That inside one will be
108.
So now, by looking at the second one and concentrating here, we've managed to work out that the pentagon internal angle will equal 102. Sorry, pardon me, 108. Because these two must add up together to give you 180.
Yeah.
So that's going to be 108. So this one here is going to be 108, and this one here is going to be 108. P's are. So we can replace the P with 108. Okay, now, have you got this part here down?
Yeah.
Okay, well, someone need to rub it off now, because otherwise I'm going to start crashing into it. Okay, right, let's put that in. Okay, 306 add x is 360. What's x equal to?
54.
Opposite of add 306 is?
Minus
it. So 360 minus 306 will give us an answer of?
54.
Mr. Saf is on the road today. You've been to MSL today? Taking some glitches. Okay, well done. Okay, lovely. Done. Okay. Okay, done. So that question there is worth how many marks? It's amazing. Actually, this one was actually worth 3 marks, but we've done much more work than the previous one that was worth 4 or 5 marks. It's much more work here that we're thinking. Done? I'm very happy with that. Okay, folks, it's going to be a bit difficult for me to do this question all the way on one go because it only shows this much at the same time, and then the bottom table's over there and stuff. So I'm going to need some of your help to give me some of the numbers and stuff. Okay. Or what we can do, we can improvise. Okay, let's improvise today. Okay, at the moment the other tables below, you can't get everything on the screen at the same time. So I'm going to improvise on this original table and add on the column called cumulative frequency. Okay, for those of you who are following this question at home, folks, the question looks something like this. We have the table at the top and then another table, and we can't get everything on the board at the same time. So I'm copying up this cumulative frequency up here so we can work in one place on the board. Alright? So please bear with me for the moment. So we can ignore this bottom part today. Alright. Are you ready, folks?
Yeah.
The group frequency table. Okay. The group frequency table shows information about the weekly wages of 80 factory workers. So Umar, so when I'm going to add all them up, what should they add up to? Should add up to 80, yeah? So let's start off. If you want to do cumulative frequency, remind what cumulative frequency is. It is called a running total. So the total so far each time.
Yeah.
So what's the first total here? Ramiz? The first total is?
8.
And then what do we do then?
Add 15 onto it.
Add 15 onto that 8, add 15. Now folks, make sure you give me the right answer now, yeah?
23.
23. And then what do we do with 23? We
Add 30.
add the?
30.
So 23 add 30 will give us?
53.
53. And then 53, what do we do to it?
72.
Okay, Mr. Zishan, are you happy with that?
73.
Yeah, Umar? 53 add the 70 will give us now?
70.
80. Total.
70. And then the 70, then we're going to add the 7. And that gives us?
77.
They've got all in, yeah?
Yeah.
And then 77 add the last number, add 3 will give us?
80.
80. Are we happy with 80 now, yeah?
Yeah.
So we have reached the number that gave us in the beginning of the question. Was complete the cumulative frequency table. We've done the cumulative frequency table. Okay, then it says here, question part B, which we can't see on the board for the moment. I'll read it out to you. On the grid opposite, draw a cumulative frequency graph for your table. That's worth 2 marks. And then we want to find out the interquartile range. And then there's another question. For the next part, we'll have to move everything up and rub it all off and use the values from one of the papers. Okay, right, we need to draw the graph. Now before we go into the graph has a cumulative frequency running along here, which axis is the cumulative frequency? That's called which axis is it?
Y.
Y-axis. Now, in the original graph here, we got y-axis from 0 to 80, cumulative frequency. On the bottom you got the weekly wage, 0, 100, 200, 300, 400 from now. In the weekly wage, we have here, Omar, 100 to 200, so which one do I plot? The beginning one, the middle one, or the end value? End value, lovely. And that will then be, what will that be called? That will be called the x value, x-axis values. So I'm just gonna circle it here. Now we're going to plot those along the x-axis. So the height of 8, okay, Ifra, the height of 8, we're going to plot it, we're going to go 200 along the x and then 8 along the y. This one, 300 along the x and then 23 along the y. So these are my x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, x, y, x, y. Are you happy with that? Here folks, so I'm going to have to rub all this off now. Okay, because I'll move the graph up here because I can't get everything on the board at the same time. So may you understand that? And then you'll have to give me those values back to me. Now I'll put them on the board. 1, 2, 3, 4. Oh, so I'll put this in the wrong place. Can you please 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 100, 200, 300, 400, 500, 1, 2, 3, 4, 5, 6, 7. No, right, that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a bit difficult for me to see on the bottom. Okay, lovely. Right. Okay, now. So we've got 200 and we've got to go to a height of. What's the height for 200? 8. So 200 and we'll go to 8. Okay, folks, when you start plotting on yours, I'm trying to do the best because it's a bit difficult for me to see here exactly what's going on. 200 is 8. There it is. Okay, we got that in?
Yeah.
Okay, the next one is 300 is 23.
Yeah.
So 20 is, yeah, and 20. Wow, now this is hitting my eyes.
Use the ruler.
Okay, next one is 400 is what?
53.
53.
53. No, I actually can't tell.
Use the ruler.
Okay.
Did you draw them up after? No. Shut up.
Okay, Ifra, can we please feel out? Okay. Okay, which one have I just, I've done 500, is that 400 one, yeah?
Yeah.
500 is 70. Okay folks, mine are going to be like really approximate because I'm really struggling with actually seeing the scale because you have to just make it so small for the moment. And the next one, 600 is 77. Okay. Right, 77 is going to be 600 from here, 7 up from there. 1, 2, 3, 4, 5, 6, 7. So mine's approximately there. And what's the 700 one? 700 one is 80. So that's 7. Okay, here.
You know what?
7, 8, 9, 10. So mine is roughly here. Okay, right, I've got my points on there. Okay for that. Okay, now, what do we need to do now? We need to to a nice curve. Okay. So our cumulative frequency, here's our first value to the last value. Right, now let's have a look. Use your graph to find an estimate for the interquartile range. Interquartile range, as it suggests, is in quarters. We have 80 values in total. If you divide 80 into quarters, what's the first quarter?
20.
And the second one is?
40.
And the third one is?
60.
So how do we do that? 80 divided by 4 is 20. 20 add another 20 is the next quarter, and the next quarter, and the next quarter. So this is the first, that's quarter way up, that's halfway up, that's 3/4 way up, and that's the full. Okay, that's all the data. Now, to do the interquartile range, you've got to look at the lower quartile and the third quartile. So what we need to do now, we need to use our ruler to go across, down, to get the value, go across and down. So let's do that now, folks. Do that with your rulers. Okay, now remember, these themselves, the lower quarter value is actually here. Okay, so the quarter of the data went up, you go across, hit the graph. So this here is actually the lower quartile. Okay, right, back to the question okay, over here. So what we said before, so quarter of the way up, across and down, that gives you the lower quartile value. 3/4 of the data up is 60th value, across and down, that gives you the upper quartile. So these are not the lower and upper quartiles, the lower quartiles here and upper quartiles here. So let's get some values off the graph. So I'm getting roughly on my one here, according to my scale, I'm getting roughly 290 for the okay. Is this part on the actual video where I'm working now?
It is, but it's a bit dark.
Okay, so come over here.
Yeah.
So the upper quartile, so the we just said that's 290 roughly for my graph. The upper quartile, I'm looking at this now, 400, 410, 420 roughly. Okay, right. So 420 minus 290 will give us an answer of, well, that gives an answer of, come on folks. What's 420 times 290?
150. It's 130.
Okay, 130. 130 is the answer to my particular graph that I've drawn, the accuracy of my graph. Now the mark scheme for this particular question, okay, let's get a quick sample of answers. Ramil, what you got for yours?
I got 440 minus 290.
Okay, so what's your final answer then?
150.
150, that's okay as well, that's lovely. 150. Samir, what do you get for yours? What's your value? 150. Umar?
Same as yours.
The same as mine. Mr. Zishan, what do you get?
150.
150. Okay, now, the mark scheme, the examiner will allow an answer here between from 120 to 160. So is everybody in that range? Okay, so anybody in that range, they're in, got the mark. Okay, now, next question. Question D. So again, I'm going to read it out from here. It says, use your graph to find an estimate for the number of workers with a weekly wage of more than 530. More than 530. Okay, what I'm going to do for this part of the question, I'm going to rub off these 3/4 and 1/4 okay, for this part of the question. Alright, this is going to confuse things a bit. So we don't need this anymore now. That's done. Get rid of that as well. So I've done that. That's 130, my answer. I'll get rid of this. because I need the space and I need to get rid of all the clutter. More than 530. Let's get my ruler. More than £530. So where's £530, folks? £530 is roughly where?
73 I got.
5. Okay. Right, can you find 530 on the bottom, please, folks, and draw lines nicely up. Okay.
Until we meet the line.
That's right, until you meet the line. Okay, folks, in front of you at the back, I hope you are focusing on the question at hand.
73 or 70.
Okay, mine's here is roughly, what's the third value there? What was that? 70?
70.
Is that 70? Yeah, bang on, was it?
Yeah,
that value there?
70, yeah.
70, so mine's according to that 70, that's 72 roughly. Approximately 72 according to my kind of difficult graph. Okay. How many data values we got together?
80.
80.
Are you doing this?
So that's the total, and we have got here. And the question says, use your graph to find an estimate for the number of workers with a weekly wage of more than 530, which basically means all the workers which are here, which corresponds to all the number of people which are here.
So
More than 530.
So do you take 72 away from 80?
That's right. 80, take away 72.
Which is 8.
So we get 8 workers. Right. I get 8 workers according to the numbers that I've got for my graph. Now, the lowest number for that answer the examiner will accept is 6, and the maximum is 9 for that. So as long as you're not less than 6 and more than 9, you'll still be able to get the answer. So the examiner has some leeway for your answers. Because everybody's graph won't be exactly the same as the person, a little bit out. So the answer to part D, was 8 workers. Done. Okay, is there any more to that question?
No.
Right, folks, are we ready? Let's write 8.2. So this is actually question number 16. Just the question number 16 has been chopped off from the corner, so I'll just put it over there. Okay, Mr. Rameez, are you happy with number 16? Ready?
Yeah.
8.2 times by 10 to the 5. Let's copy down the 8.2 over here. Okay, now time by 10 to the 5. Okay, Rutaba, what does that mean? Time by 10 to the 5.
You add 5 zeros.
We,
Take it, add 5 zeros.
that's close. We don't add 5 zeros in this situation, otherwise I can say my answer. We have to move the decimal point 5 places to the right. Because in a sense what we're doing, we are multiplying 8.2 by 10 5 times. So 1, 2, 3, 4, 5. Drop the decimal point here. Now what we do now is we will copy down. So Rameez, 8, 2, what do we put in the empty gap?
0.
In the other empty gap?
0, 0, 0. And then dot 0.
Okay, so at the moment, 8.2 times by 10 to the 5 gives us this answer. Do we need to keep the decimal point at the end? Do we need it there?
Nah.
For the first part is okay, but for the final answer, we can get rid of it. So that is the number done. Next question, part B. Everyone ready for the next one? Write 0.00376 in standard form. Now, to get standard form is A times by 10 to the power of n, where A is the number between 1 and 10. So to make this number between 1 and 10, I have to move that decimal point from here to here. And that'll give me my A value. So what is my A value then? So if I put the decimal point there and I move from there to there, what will it read now, that number? The number will now read what?
3.76.
Excellent. 3.76. Now time by 10 to the power of n, now we have to put in the instructions here in the power to tell us how to get back to the original number. If the decimal point moves from here to here, to get it back, what do? We go 1, 2, 3, we move 4 to the left, so that n will be minus 4. Okay? So 3.76 times by 10 to the power of minus 4 will reconstruct our original number, which was 0.000376. Yeah? Done. That question is done. Okay, next question. Work out the value of this, give your answer in standard form. So what I'm going to do, I'm going to rub this stuff off here now, folks, and move that question up. So are you ready to move it up? So work out the value of 2.3 times by 10 to the 12 divided by 4.6 times by 10 to the 3. Most students will look at this in the examination get frightened because they think, oh, well, how do I do that without a calculator? So most of the students' lives revolve around calculators. Alright, let's see how we do that. Can somebody tell me what the sign here is? Divide. Another way of writing divide is by putting a sign. I'm just going to rewrite the question because I'd like to see it in this form. Okay. Right. We're going to do this question in two parts. Here's the first part. Okay. Mr. Hamza, 2.3, that line means divide by 4.6. What's 2.3 divided by 4.6?
1.3.
I was thinking it's going to be more like 0.5.
Maybe,
Yeah, because that's double of that when you divide something. Yeah? 2.3 divided by 4.6 is 0.5. Here comes the next part. What's 10 to the 12 divided by 10 to the 3? That will give you what?
10 to the
9.
10 to the power of 9. Now, when we divide them, these numbers are the same. We minus the indices, 12 minus 3 is 9. That's good. Okay, the question says, give your answer in standard form. And what do most students do? They get to this place and what do they say? Yes, I've finished my answer. I'm ready for the next question. Have you finished?
No.
No, because this number is not between 1 and 10. Standard form, the first one is between 1 and 10. So at the moment, from here, how many times do we jump to the right?
9.
9. But the decimal point shouldn't be here. The decimal point should be
There.
So we have 5.0 times by 10. If I move the decimal point one place forward, I won't jump 9 places my answer. I'll jump only 8 places. You don't need the point numbers on, by the way. So that divided by that gives you 0.5. That divided by that gives you 10 to the 9. But then you have to adjust it to make it into proper standard form. So that gives you final answer 5 times by 10 to the 8. And that's the end of that question. And altogether, those will worth 4 marks in total. Let's make this one a little bit more chunky. And that's looking lovely. This here, folks, is question number 17. I'm just writing in there because it's been chopped off in the enlargement process. Right. Solve 4x minus 1 divided by 5 plus x plus 4 divided by 2 equals 3. It says solve it. Okay, by the time most students get to this, they're ready with the parachute on, ready to jump out the window. Nothing to jump out the window for. We need to, first of all, to solve this. If I got rid of all this, folks, at the bottom, does that question look easy to solve? If I got rid of the fraction at the bottom, does it look more kind of sensible because you've got a linear equation, 4x minus 1 add x plus 4 equals 3, yeah? It looks like we can simplify it and solve it easy. So, if I get rid of the fraction, it's easy, isn't it? How do we get rid of the fraction? We have a 5 and a 2 on the bottom.
You times it. Make them equal.
We use the LCM technique, the lowest common multiple of the 5 and the 2. What is the lowest common multiple of 5 and 2? It's 10. What we're going to do now to eliminate the divide by 5 and to eliminate the divide by 2, the fractional part of it, I'm going to multiply each element by 10. And that will get rid of that and make the question easy for us to do. So, right, I'm going to multiply this first part by 10. I'm going to multiply the second part, this second element by 10. I'm just trying to write it in such a way that it looks kind of natural. Okay, I'm just going to have to squeeze in here a bit. Okay, now, have I finished? I'm missing the out. One bit left, isn't there? I see I'm going to multiply everything by 10. So multiply this element by 10, this element by 10, and also the 3 by the 10. That's where most students make a mistake in the exam. They forget to multiply that side by 10 as well. That's called keeping the formula balanced and equilibrium. So now let's start doing some cancelling. What was the point of multiplying by 10 to get rid of the and the 2? So this here, times by 10 divided by 5. What can I do with these two? Opposite. So I can cancel them by dividing them by 5. 5 divided by 5 is
1.
10 divided by 5 is 2. So that's okay. So now I'm going to cancel this one. with that multiplier. So we're timesing by 10, dividing by 2. So we can simplify. So 2 divided by 2 is
1.
and 10 divided by 2 is
5.
we are dividing by the bottom number because we know we'll go in there because we've done the LCM. So now, what can you see at the moment? The 5 has now been cancelled. It's been officially cancelled, gone. So let's rewrite it out now and make it all look nice and lovely. So 2 multiplied by 4x minus 1 plus x plus 4 times by 5. Okay folks, don't feel kind of like, oh, hang on, that's on the left and why that's on the right. It doesn't matter which side's on. Okay? So nothing you're worried about. 3 times by 10. Okay, are we happy with that so far?
Yeah.
Okay, what technique did we use in the beginning? To get rid of the fractional parts, we found the lowest common multiple of 5 and 2, which was 10, and multiplied everything by 10. First bit, second bit, and third bit. We've cancelled off the bottom parts now by cross-cancelling over here, and now we've got this situation. What should we do now? We should now multiply the brackets, collect like terms, we should simplify and solve. Multiply our brackets. Let's go. 2 times by 4x is?
8x
2 times by minus 1 is?
minus 2.
Okay, now we have here 5 times by x is?
5x
We have 5 times by plus 4 is?
20.
Plus 20. And 3 times by 10 is? 30. Now let's collect like terms. So we have 8x and 5x. 8x and 5x will give us a total of?
13.
13x. Okay, now we have minus 2 and plus 20.
Plus 18.
That will give us plus 18. And that will give us equals to 30. Now, in order to solve this for x now, that's our first action and second action. Opposite of add 18 is?
Minus.
So what's 30 taken by 18?
12.
12. Okay, what we left over here is?
13.
13. So, let's just copy that. 13x. Now, opposite time by 13 is? Okay, so our final x is x is equal to 12 over 13, which is a proper fraction. Okay. Now, don't get worried, folks, if you see that. Okay. Don't always expect to get a whole number answer. Most of you look at that answer and think, well, that looks wrong, or no, I've never seen that kind of answer before, yeah? 12 over 13 is, look, that is the correct answer. Question number 18. Right, question number 18, I'm going to read it from the exam paper while you guys look at this grid here. Shape P is reflected in the line x equals minus 1 to give us shape Q. Shape Q is then reflected in the line y equals 0 to give us shape R. So let's describe fully the single transformation that maps P onto R. So we're going to do two parts of the transformation first of all. Now, x equals minus 1. Whoops, that was a close one. X equals minus 1. Where is x equals minus 1, folks? X equals minus 1 is physically here. That's where it is. That's the point x equals minus 1 on the grid. Where is the line x equals minus 1? The line, where is it? It is
straight down.
Straight up. Okay. This is the line. Even though the x-axis is horizontal, the line x equals minus 1 is a vertical line. Why is it vertical? Because everywhere on that line x has a value of minus 1. Okay, so I'm going to label that here. X equals minus 1. Now we need to first of all reflect this shape into this line. That's the mirror line. So let's do the reflection. Are you ready for the reflection? So when you do reflection, it's all about distance, perpendicular distance from the mirror. So I'm going to look at 1, 2, 3, 4 points. This point. Okay, Hamza, how far is this point from the red line? How far? How many squares? 2. So if it's 2 on the right, it will be 2 on the left. This one, Ramiz, how many squares from the line? 1,
Four.
2, 3, 4. So on the other side will be 1, 2, 3,
and 4.
3 and 4. This one, Rutaba, how many squares is away from the mirror?
2.
2. So 2 here will be 2 there. Samia, how much is that one? Don't say 4.
3.
1, 2,
Five.
3, 4,
5.
5. So 1, 2, 3, 4, 5. So if you join this up now, you get this. So that is called shape Q. Then it says shape Q is reflected in the line y equals 0. Let's find the line. Let's find the point y equals 0 first of all. Where is the point y equals 0? The point y equals 0 is?
0 line.
Okay, is the x-axis then. Alright, so let's use that. Even though I don't need up here, I'm just going to label here the y equals, the x-axis is the y equals 0 line. So we've gone from here, we reflected it this way, now we're going to reflect it that way. So we do exactly the same thing. We've got to grab 4 points and measure the distance or count the distance and do it on the bottom. Okay, here we go. Right, Asaf, this point is how many squares away from the line, mirror line? 1. So 1 here will be 1 below. Ramiz, that point is how many from the mirror?
3.
3. So 1, 2, 3 is here. Okay, Mr. Hamza, how many points is that one from the middle line? That is also 3. 3 from here, 3 straight down here. So that is you there. And this one, let's have Mr. Umar. How many points from the mirror? How many spaces?
4.
1.
1.
And then 1 here.
Yeah.
Okay. Okay, describe fully the single transformation that maps shape P onto shape R. Okay, for that, we need to look at these 2 shapes now. We need to say, how does this shape get to this shape? Now, what we need to do first of all, okay, folks, shall I? Is it okay if I rub this one off now? We've got time, haven't we? Okay?
Yeah.
Okay, let's rub that off for the moment. Oh, maybe we just see if we can get away with it. No, let's take it off. We don't need this anymore. Now, what we need to do first of all, we need to join up corresponding points. So, this point here corresponds with which point?
That one there.
Yeah, let's join them up. The ruler.
It's -1. X equals -1.
1 second, let me hang on.
Okay. Yeah, it is.
Okay, now we need to join up 2 other corresponding points.
No, that's not it.
So, should we choose this one here? What does that correspond to?
2.
This one here, yeah? Corresponding points. So that point has come over here. You've got to join them up now. So we are now looking for where the purple line intersects the black line. So these 2 corresponding points and these 2 corresponding points, where do they cross? They cross.
-1.
They cross at -1 and then what's the x coordinate?
X.
Sorry, the x coordinate is -1, the y coordinate is?
0.
0.
Okay, now, so can somebody explain to me what is the transformation in that case then? What is it? What does it look like to you guys? So the question goes, describe fully the single transformation that maps this to that. So the first one we're going to write down is?
Rotation.
So this shape has been turned all the way around. So rotation, how many degrees?
180.
Now, if you write 180, do we need to write down clockwise or anti-clockwise? Normally we do. Do we need to write down clockwise, anti-clockwise if it's 180?
No.
No, because it doesn't matter if you go clockwise or anti-clockwise, it's the same. Half done. 180, rotation, 180, and where is the rotation about?
-1, 0.
Done. That question has 3 marks for it. 1, 2, 3. Yeah? It's a rotation, it's a 180 degrees rotation, and about -10. So that will give us the answer for that. Number 19. Number 90. Let's have a look at this question. Diagram not accurately drawn, that's not there for a joke, folks. Please do not start measuring stuff in the exam. That's what that means. Don't start measuring, it's like a sketch. A, B and D. A, B and D are points on the circumference of a circle center O. Say A, B and D. O. B, O, D, bod. So B, O, D is the diameter of the circle. So they're telling you that. BC and AC are tangents to the circle. So this one here and this one here are tangents. I'm going to put them in purple. Okay, now normally when we have tangents drawn in the questions that we do, the tangents normally do they stop at the circle or do they carry on going? The one that we normally see. Carry on going. So I'm just making mine slightly longer. So it looks like a tangent to me. Okay, now that looks nice now, that's tangent. Okay, angle AOC is 34. Angle OCB. Angle O to C to B is 34, which is that one labeled there. Work out the size of angle DOA. DOA is that one. Angle DOA. Now, one thing to point out here, in the previous question when we had an angle question, I'm just going to flip back to the exam paper and look at the question that we done earlier, which was okay, when we done question number 10, work out the size of the angle, you must give reasons for your answer. Is that sentence here in this question? Okay, it just says work out the size of the angle DOA. So you know before we said this is equal to this and this is that and this is this and this is that. Remember all those statements? You can make them if you want to here, but that's not necessary. I want you to work it out. Okay, so let's have a look how we do that. Now, let's start putting down some calculus, some things that we know. Now, O to B, what's that called? The line O to B, what can we call in a circle? O to B is called what? The distance from the center to the outside of the circle is called what? Radius. When a radius meets a tangent, what angle do they meet at? 90 degrees. Okay. Is this another radius by chance? Okay, that one is there, but we're not into, actually I've gone the wrong way. Pardon me. Wrong one, I'm looking at the wrong one here. This one here. Okay, this is the radius, and this is the radius, and they both are meeting a tangent. So they both must meet the tangent at. I'm going to make a nice little statement here on the side. So I'm going to say here, when the radius, so the radius is going to be OA and OB. OA and OB meet a tangent. Okay, tangent is AC and CB. They meet at 90 degrees. So that gives me my 90 here, and that gives me my 90 here. So I just made a little statement. Okay. Now, if we start from the point C and we go to A, from that same point we go to B, what can we do? What can we tell from that kind of diagram? If we start from the same point, what will that angle be? This angle will also be 34. It's symmetrical. Okay, now, okay, that's looking good so far. So we know this, we know that, we know this. Okay, now, let's have a look at this triangle here, which I'm going to do in black. What can you tell me about this triangle here? This triangle is called a right angle triangle. 90, 34. What's missing from the triangle at the moment? To make 180, what do we need? goes here. So that's 90. These two must add up to 90. That's already 30. So this will be what? 50. 56. Okay, that's 56, and this bottom triangle is the same as the top triangle. This angle will also be 56. Now, can we now work out DOA now? So we can say now, here's my second statement. Angles at a point. That's the key word here, folks. Angles at a point. So you need to stop writing down angles on a straight line. That's not mathematics. Angles at a point, which is this one here, at a point O on a straight line. Straight line is DOP. Okay, angles at a point on straight line add up to, what does it add up to? 180. So this angle at this angle will give you 180. So let's just change color a bit. So we say DOA add 56 is equal to 180. So making that statement. Okay, 56 add 56 will give us 112. Okay, now, Mr. Umar, the angle that I'm looking for, we just literally step away now. DOA, this angle, add 112 is 180. What do I have to do now to get the DOA? Grab the 112.
And take it to the side.
Take it to the side. It was a plus 112, becomes a? Okay, so now we can say the DOA, does the red color come here? Okay.
Yeah.
So the DOA will be equal to 180 minus 112.
Which is 68.
That will give us
68
degrees. DOA is 68 degrees, and we've done that question. Okay. This next question is question number 20. Part 1, it says factorize this is a quadratic equation where the A coefficient is 1, which is the nicest one you can have. Okay, is this one you can go? No problem. Can you take this paper with you to do for homework? See you next week, inshallah. Yeah, grab that. Leave your homework behind, the one you got to hand it to me on the table. Make sure your name's on there. Okay, we've got to factorize x squared minus 12x plus 27. A quadratic equation given in the format with the A value at the front is one's gift. Right, we are now looking for, let's set it out. The answer is going to be in this format. We are looking for two numbers that when you multiply them together, they give you an answer of, what do they give you an answer of? Plus 27. When you multiply these two numbers together, they give you plus 27. And when you add these two numbers, they give you an answer of minus 12. So we are now going to be considering the, we are now going to be considering the factor pairs of plus 27, which add up to minus 12. Now remember, they're going to add up to minus 12, so we need to consider the negative factors, isn't it? So let's have a look. So 27. How do we make two numbers times to give 27? It will be minus 1 times by minus 27, or minus 3 times by minus 9. Okay, which one of those do you reckon we should use?
The bottom one.
Okay, if you wanted this factor list to be exhaustive, then you need to put this one on as well. But that actually wouldn't help out with that question because we need to get a negative answer, but that's an exhaustive list of all the factor pairs, and multiply will give you that. So that's the one we're interested in. So what do we do with those minus 3 and minus 9?
In the brackets.
Now, does it matter the order I put them into?
No.
It doesn't matter the order because the coefficients of the x here is 1 and 1. If that was 2 or 3, then the order is very important. So we have now factorized it. Okay, the next question says solve the equation, which is the same one. We have to solve the same equation now. When we solve this equation, we have to make it equal to 0. To make it equal to 0, we say if I got this numbers here and this number here, two numbers which are going to multiply together to give you 0. What fact do we know? One, the brackets must be equal to 0. So we say either x minus 3, the first one is equal to 0, this first bracket will give us total of 0 to give us an answer of 0, because 0 times by whatever is 0, isn't it? So x minus 3 is 0, so the x value will be equal to 3. So opposite of minus 3 is Hatfield. What I'm doing now, I'm teaching you here, this is the pure mathematical method. The method, I'll show you this shortcut method as well. So we say either this first bracket is 0 or the second bracket is 0. So what will be the value of x then? So x has the value of, it's opposite of minus plus 9. This is in a sense the long way of doing it. Let me just show you the quick way of doing it. In this kind of situation here, what's opposite of minus 3?
Plus 3.
That's the first answer. What's the opposite of minus 9?
Plus 9.
Plus 9, the second answer. How long does that take? 2 seconds? Okay. So if you want to do a quick examination, just reverse what's in there. If that's minus 3, the solution is plus 3. If that's minus 9, the solution is plus 9. That's after all that working out. And if it's plus 3, it will be minus 3 and so on. Just reverse it. Okay, that one's done. Okay, factorize y squared minus 100. Students' first reaction, factorize y squared for minus 100 is, how do I do that? There's no common factors. We're not doing common factors in this question. This is called the difference of two squares. So, IFRA. Y squared is quite obvious. That's a square number. That's y squared. What is 100?
10.
Squared. Yeah? 100 is not 10. 100 is 10 squared. So here we have two square numbers, y squared and minus 10 squared. Now, when we put them into our answer, what do we get? We copy the y down, the minus 10, and then we copy the same thing again, but we make the second minus into a plus. Okay, if you look at the algebra for it, a squared minus b squared will factorize like this. Okay, and that's done, that's finished. It says factorize, we've done it. If you were to multiply this out, you get exactly y squared minus 100. That's done. Prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. Okay, integers means whole numbers. So for example, if you're looking at numbers, what's the consecutive number to 2? The next consecutive number is 3. And if I add 7, the next consecutive number to 7 is 8. That's what we're looking at numerically. We have to look algebraically. So the 2, we're going to call it n or x, yeah? N. And the next number, the next consecutive number to n would be n
Add 1.
and add 1. Okay, so 2 add 1 is 3. If you look at it numerically. Let's get rid of this now. They want us to prove that the difference between the squares of those two numbers is the same as the sum of them. So let's add them up first. So let's go to this. So n is the first consecutive. N is the first integer. That's the second integer. They're consecutive. That means one follows after the one. Okay. Now let's add them up. What's n at n add 1?
2n add 1.
So we have to prove that after we square them and minus them, it gives us that total. So let's do that now. Now, the difference between the squares, when you work out the difference, you always start with the large value minus the small value. So, let's go back to our original first number. It's consecutive number. Which is the larger out of these two?
The second one.
The second one. So we have to do now n plus 1 squared minus, because the question says here, prove algebraically that the difference is here between the squares of any two consecutive numbers. Difference means the larger the square number minus the small square number. So we got to prove that when we do all of this, it's going to give us that. So let's work that out now. So n plus 1 squared means what? What does it mean? It means n plus 1 times by
n plus 1.
n plus 1 minus n squared. Let's multiply this bracket. We start the first element here, n, and we multiply by each of the other two elements. So what do we have now? N times by n is?
N squared.
N times by plus 1 is?
Plus 1n.
Plus 1n or just plus n.
Yeah.
Okay.
Plus n again.
Yeah. Next one we have, we start the second element. Plus 1 we multiply by the n and then by the plus 1. Right. What's plus 1 times by n?
Plus n.
Plus n again. What's plus 1 times by plus 1?
Plus 1.
Plus 1. And then we got minus n squared at the end. Okay, right. We need to simplify that. So Saf, I have an n squared here and a minus n squared here. What happens to those two? They cancel each other out, they become 0. Because n squared, take away n squared is just nothing. So what we left with is n plus n, which is?
2n at 1.
Okay, so does this give us the same answer as this?
Yeah.
Yes, done. Okay, question number 22, folks. I'm going to come back to that in a bit. I'm going to use the visualizer and put that question into the video, because that's quite difficult to do on the board with the scale factor minus half and stuff. Question number 23. The diagram shows a solid hemisphere. Solid hemisphere. What is a sphere? Sphere is a ball.
A ball.
A ball, yeah? A 3D shaped ball. A hemisphere means half a ball. Of radius 5 centimeters, that's a radius. Diagram not accurately drawn, so again, please don't start measuring and stuff. And find the total surface area of the solid hemisphere. Give your answers in terms of pi. That means you don't need to physically work out any numbers. Start multiplying by 3.14 and that. Okay, right. What we need to do first of all, to work out the surface area of a hemisphere, I want everybody to turn to the first page, inside the first page of the exam paper. You'll have a formula sheet there. And we have here the surface area of a sphere.
4 pi r squared.
4/3 pi r.
No,
And that's the volume.
That's volume.
Okay, 4 pi r. Okay, 4 pi r squared. The surface area of a hemisphere is 4 pi r squared. Good. Now, that's the surface area of a sphere. We've got a hemisphere. So what do we do that formula, Ifra?
Half it.
So we have to half this formula.
2 pi r squared. Or 2 pi r squared.
Okay. So the total surface area is going to be half that what we got, 4 pi squared divided by 2. And then what we're going to add to it, we're going to work out the area of the half of the curvy part of the ball shape, curvy part, and we're also going to work out the area of the flat circle, the flat base, which is the circle, which is the bottom part there. And what's the area of a circle?
Pi r squared.
Pi r squared. Okay, right. Now what is the value of the radius?
5 centimeters.
5 centimeters. Alright, should we put 5 in those places and start simplifying now? Yeah?
Yeah.
Should we go for it? So we're going to do now 4 times by pi times by
5 squared.
5 squared
Over 2
divided by 2 plus pi times by 5 squared. And what can we do with this 4 and that 2 there?
We're just
We can, 2 divided by 2 is 1, 4 divided by 2 is 2. So 2 times by pi times by 5 squared. What's 5 squared?
25.
What's 25 times by 2?
50.
So what's 50 times by pi? 50 pi.
50. Yeah.
Okay, what's 5 squared? 25. 25 times by pi is?
25
pi.
And what's 50 pi at 25 pi?
75 pi.
So it was give your answer in terms of pi and that question's done. We're looking at question number 22. Okay, which is looking at enlarge the shaded shape, which is this one here, by the scale factor minus a half, minus 1, minus 2. This minus here indicates that we have to first of all find our center minus 1, minus 2, so minus 1, minus 2 over here. That's our center. Okay. And the minus indicates rather than the enlargement being ahead of the shape, as in traditional case, that minus indicates that we've got to bring the they are called my spider lines. Rather than going ahead of the shape, you have to bring it this way through the center of enlargement, bring it in the opposite direction instead. I'm going to draw our lines, spider lines. So each point, you're going to bring them through the center enlargement that way, rather than going ahead of it like in the normal fashion. So each point on our original shape. So this one here, going through here, and the same for the top one over here. That goes through there, and then our top point over here. So that top point going through the center. There. Now what we need to do, we need to reconstruct this shape on the other side upside down and half the size. That's what the -1 afterwards. Okay, what we need to do now, if I just call this A, B, C, D. So each corner of my shape, so A has to go down its own line onto the opposite side, but this distance A will have to be halved. And one way we can do that is by looking at this X and Y coordinates and halving those on the opposite side instead of measuring this and making mistakes in our measurements. So A is 2 across and 1, 2, 3, 4 up. So on the other side it will be 1 across, and rather than 4 up it will be 2 down. Half was 2. So 1, 2. So the point A travelling along its line will be here. That's my A dash. So let's go ahead and put all of these now. That's done. If I want to do B, B from the center is 2 across and 1, 2, 3, 4, 5, 6 up. So rather than going 2 across on the other side, when you do the reflection, it will be 1 across, rather than being 1, 2, 3, 4, 5, 6, it will be 3 down. So 1 and 3 down will give you this point here. That's B done. Okay, that's better. Okay, now we're going to do the same for C. So from the center, C is going to be 1, 2, 3, 4, 5, 6. 6 across. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8 above. Half of 6 across this way is going to be 3 across that way. Half of 8 up will be 4 down. So it will be there. And here's another point. Okay. That part's done. Next, now we're going to do D. So to get, let's put all this off. So to get from the center to D is going to be 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4 up. So the half of 6 across is 3 across. 1, 2, 3. Half of 4 up is going to be 2 down. So it's going to be here. Now we can join the shape up. And that is our new shape. Question 24. There are 3 different types of sandwiches on a shelf. They are 4 egg sandwiches, 5 cheese sandwiches and 2 ham sandwiches. Erin takes at random 2 of the sandwiches. Work out the probability that she takes 2 different types of sandwiches. We can work out literally as they've said it, work out what the probability of getting each different type of sandwiches, but that would be quite a long list of working out the different types of sandwiches. So egg and cheese and egg and ham, all the different combinations will be quite a bit. So what we're going to do, we're going to do a different technique. We're going to, well, we can get 2 types of outputs if we work out the probability. We can get either the sandwiches when you pick them will be different or they'll be identical. So those two events together add up to 1. So we can use that 1 minus technique. So we are going to say the probability of getting the different sandwiches is equal to 1 minus the probability that they will be the same. So that's another like shorter way of doing the same question. So what we're going to work out now is we're going to work out the probability of getting 2 egg, 2 cheese and 2 ham, and then add them up and minus it from 1, and that will give us the answer as though we worked out 2 different types. So let's first of all look at that question now. Now, probability of an egg sandwich and the probability of an egg sandwich is equal to. Now, probability of the egg sandwich is going to be equal to 4 out of, we've got 4 out of 5 is 9, 9 out of 2 is 11, so there's 11 sandwiches altogether, so 4 out of 11. The and means multiply probability of the next egg sandwich. Now we picked one egg sandwich, so this 11 has now become 10. You had 11 sandwiches, 1 was taken out, now you have 10 sandwiches left over. 4 of them were egg, now you got 3 left over. So this is called probability without replacement, Okay, what we can do, I'm going to copy this bit down over here. So we're going to copy this and make it all into one nice big calculation. Okay, let's get started. So the probability of 1 minus the probability of an egg and an egg, or it's going to be the probability of a cheese and a cheese, probability of cheese and the probability of cheese of the 2 sandwiches, or we have probability of a ham and a ham. Okay. Now remember this. Whenever you have an anti-probability it means times, whenever you have an or it means plus. So let's change colour a bit and put those in straight away. And means times, and means times, and means times. Okay, probability of my first. I'm just going to copy this down over here. Probably be better just bring it like this now. So you have 4 over 11. 11 sandwiches, 4 of them are egg. Pick one of the egg ones out. You have 3 egg ones left, and you have 10 sandwiches left. Or means plus. I'm just going to copy the plus down. And actually, the plus is right there. We just need to make it a bit bigger. Okay. So we have probability of the cheese. There's 5 cheese sandwiches, so it's going to be 5 out of 11 if you pick a cheese first, and then you have 1 cheese out, you got 4 cheese left, and you have 10 sandwiches left. So the second fraction is changed. And plus probability of a ham, you have 2 ham sandwiches, probability of ham is 2 out of 11. Once you picked 1 ham sandwich, you have 1 less, or 2 minus 1 is 1. You had 11 sandwiches originally, but now you have 10. So that gives us that calculation there. So what I want to do now, because we haven't got that much board space left over, I'm going to do some calculations above here. So 4 over 11 times by 3 over 10. Well, 4 times by 3 is 12. 11 times by 10 is 110. So the first part gives us 12 over 110. Okay, and then we can add to that this one. 5 over 11 times by 4 over 10. 5 times by 4 is 20. 11 times by 10 is 110 again. Okay, the next one plus 2 times by 1 is 2. 11 times by 10 is 110 again. And remember, all of this 1 minus it. Okay, I'm having to copy this from here to there because we have running out of actual board space that we can actually record on. So let's work this out. 12 over 110 plus 20 over 110 plus 2 over 110 is fantastic. All the denominators are the same. At the top now, 12 at 20 is 32. 32 at 2 is 34. Okay, so if you have one whole, remember in one whole, if you change it into 110ths, one whole is the same as 110 110ths. Here this now. That's one way of looking at the one whole. So one whole is 110 110ths minus the 34 110ths. So the answer to question number 24, that was the idea, and the answer is up here, which is 76 110ths. Okay, which I'm just going to circle around here so we see that clearly in the video. That, folks, is the answer. Here we have question 25, y is equal to f of x. F of x is a generic way of the examiner saying this is a function of x, without them having to spell out, or without them having to write out the full function. For example, this here is a quadratic function, without them having to write out y equals x squared plus 3x minus 7, whatever they might be. And this right hand y equals f of x. So get used to that in the examination style of the question. So the graph of y of f of x is shown on the grid below. Here it is. Question A says, on the grid above, sketch the graph of y is equal to minus f of x. So we started off with y is equal to f of x, and now we have to draw y is equal to, it looks like exactly the same, but here we put a minus outside. That minus is like, it's the same as multiplying this function, the output of the function, by a minus 1. So whenever you work out the function, you have to, in a sense, what we're doing is we are reflecting the function in the x-axis. The x-axis then becomes a mirror. If the minus is on the outside, we get this function here, and we flick it down using this as a mirror line. If the minus was on the inside of with the axis, then you would reflect it in the y-axis instead. So let's do what it says. Minus on the outside, use the x-axis as a mirror. So let's define the x-axis. Okay, yeah. So this is my mirror line. Okay, and there's my actual function. Here it is. So what we're going to do now, we're going to start to get each individual point and start bringing it down. So now remember, as we said before, if you have any point of the original image, the original touching the mirror, it stays there. So that point stays there. This point, which is 1 square above, becomes 1 square below. And this point, which is 1 square above, becomes 1 square below. Okay, now let's have a look. This point here moves down straight by 2, and it ends up roughly here. This point at 4 comes all the way down to minus 4 over here. And this point, which is slightly ahead of minus 4, which is around about here. So that point there comes to here. Same here, that point here, I'm going to bring it straight down as though I'm bringing it virtually in my head. So that next point is one here, bring that straight down. It was 4 above, it will be 4 below. And the next one is the same as, so that one there, we bring it straight down and it will be around about here. So what we can do now, we can join them up. Okay, get rid of these points in here so we don't get confused. We don't go up there. Right, here we go. Bismillah. Let's see if we can get this done nicely and smoothly. There we go. That's beautiful, mashallah. Okay, apologies for any roughness in the lines. It's very difficult to draw on the board. So we now have this is y is equal to minus f of x. That's the first part done. Now we need to move the graph up to show you the second part. Here comes the second part of the question. So we've got the same function again, because the graph of y f of x is shown on the grid. Here we go. It's the same one we just used earlier. The graph of g, which is that one there, is the translation of the graph of y equals f of x. So this has now moved to there, translation, right on the equation of graph g. Now, as we studied in the previous, if you look at the previous videos that we've done on YouTube, when the graph is translated along the x-axis, it has a certain way we write it down. So normally a y is equal to f of x. That's our original function. Now if you move it to the right, okay, normally you think of the right as positive, that will have a minus number inside it. If you move the graph to the left, we've got to have a plus number inside it. Now, as you can see, the original graph from here is moved to the right. Okay, so that's going to have a minus. We're going to say that this function here is going to be y is equal to f of x minus. Now it was at minus 2. Now it's moved 1, 2, 3, 4, 5, 6 places to the right. So the change, actually I should have done this in red actually. Let me just rub this off and put it back into red. Right. So if you look at the original function f of x, the change has been done now inside the function itself. Because it's moved to the right, we use a minus. If it was to move to the left, we'd use a plus. Okay, and that's the answer. That's the end of that question. And that question in question number 26. Question 26. It says OAYB is a quadrilateral. O to A is the vector 3A. O to B is represented by the vector 6B. Express A to B in terms of A and B. Okay, I'm just going to go over these vectors in purple. Okay, them are the vectors that have been given so far. Now it says the diagram not accurately drawn, so don't start measuring things on there and say, well, this is 3 years, so that will be proportion and so on. And you've also been given one other vector, which is b to y. Whoops. Okay. Which is 5a minus b. Okay, so that. So this vector here is 3a, that's 6b, and that's 5a minus b. Let's make that a bit more clearer. 5a minus b. Okay. So these three vectors have been given to us in the beginning of the question. Express a to b. Right, now, if I want to start at a, express a to b. I want to go from A to B, which is that straight way. Because this particular route hasn't been given a vector, it hasn't been assigned a vector in the question, we have to go on what I call the scenic route. So we've got to go from A to O, and then we've got to go from O to B. Okay, let's write that down. So A to B is equal to A to O, and then plus O to B. Okay, now A to O, if I go from A to O, we are going in the opposite direction of 3A. 3A is going this way. Vectors are directional, so if you travel in the opposite direction of a vector, you must reverse it. So the 3A becomes a minus 3A, because we're going, that's going this way, we're going in the opposite flow. O to B is in the direction of 6B, so that just stays as standard plus 6B. And that will now give us A to B. Okay. Nicely done. Right. So we worked out part A, expressed A to B in terms of A and B. We've done that. At the moment I can't write the answer in the right place. That is what the answer is. Please copy it down. Now, I'm going to be rubbing that off soon because I'll need more space. We'll see how it goes. Okay, the next part of the question. Okay, I'll have to read it out to you because I can't move the board around. I'm going to lose the diagram. So we've done A to B. X is the point on AB. X is the point on AB such that A to X and X to B is a ratio of 1 to 2. So they're telling us here that a to x is 1 and x to b is worth 2. And the way we look at that ratio is, we have 3 parts, 1 and 2 is 3, so that 1 is worth 1/3 and that 2 is worth 2/3. So 1 out of 3 and 2 out of 3 of the way up. So this here, if I go from a to x, this will be worth 1/3 of whatever this vector here is, and this one will be worth 2/3. Now, the vector that goes from a to b, we've just worked it out as minus 3a plus 6b, so that's going to be 1/3 of that. This second part from here to here will be worth 2/3 of that. So let's put that in. Okay, and let's write that bit slightly over here. 1/3 of minus 3a plus 6b. Okay. And from here to here, let's write it in a better place, is going to be 2/3 of that same vector a to b. Okay, so a to b, this vector here is minus 3a plus 6b, because we just worked out by going on the scenic route. Now that we worked that vector out, they want us to apply this ratio to it. So they're saying this is 1/3 of the way, because it's 1 part out of 3. This next part is worth 2 out of 3, so it's worth 2/3 of the way. So I've written 1/3 of the vector, 2/3 of the vector that we just worked out. Okay, now the question saying here that we need to work out, so we put that information on, and by is equal to 5a minus b, which we've already mentioned earlier. Prove that O to x, so we now got to work out O to x is equal to 2/5 of O to y. Now if we want to go from O to x, we have to go obviously again scenic route this way and that way, so that's what O to x is, this one and that one. To work out O to y, we need to go again on the scenic route because we don't know what this vector is. We're going to go this way and that way. So let's work those ones out first. So we need to prove, part B, it says prove O to x is equal to 2/5. So that's what part B is. Now first of all, in order for us to prove this is equal to that, we need to know what O to x is and we need to know what O to y is. Let's do that first. So off we go. Right, O to x. Now let's get rid of this now, we don't need this here anymore. Okay, if I want to go from O to x, I can't go on the direct route because we don't have a vector to describe it. I have to go on the scenic route, which is this way and that way. So I've got to go O to a first. So O to a is in the direction of 3a. Okay, and then I have to go from, after I got from a, I got to go from a to x. Now a to x is in that direction, 1/3 of minus 3a plus 6b. Just checking that we got all that part in without it being clipped out from the video. That's lovely so far. Now what we need to do now first of all is, before we finalize the O to x, we need to multiply this bracket to release the a from the bracket, and then we can simplify like terms, the a's and a's, and give us a, let's work that out. So what we do now, don't forget here we have a plus 1/3, we're going to multiply it by the minus 3a, and then multiply it by the plus 6b. So let's do that now. So the 3a element at the beginning stays as 3a. 1/3 times by minus 3. 1/3 of minus 3 is minus 1. So that will be plus and a minus. When you multiply and the signs are different, the answer is always minus. And 1/3 times by 3, or 1/3 of 3 is 1. So minus 1a. Okay. That's what it is, calculation. Now we don't normally write down minus 1a, but for a moment we'll do. So So 1 plus 1/3 times by plus 6, so a third of 6 is 2. So they're both positive. So that gives us 2b. So we have now successfully multiplied the brackets, gives us this. So let's now simplify it. I have 3a minus 1a, that'll give you 2a plus 2b. And that is what O to x is. Okay, so we worked out O to x. Now we need to work out O to y is. Now you have to be careful with space, because these pointers here mark the bottom where the video can record up to. So I think we're going to start over here and then try to see how far we can get. Oh, I think we should give it that now. We don't need this here anymore for the moment. Let's work out O to y over here. As we said before, to get from O to y, we cannot go direct because we have no vector describing it anywhere in the question. But we do know the scenic route, which is going to be from O to B and then B to y. That's one particular route that we could take. So O to y is equal to O to B plus B to y. Okay, so we can go this way and then that way to get from here to there, from O to y, scenic route. Now O to B is in the direction of 6b, so it stays at 6b. It's not in the reverse direction. And then B to y is in the direction of 5a minus b. Okay, now what we need to do, we need to simplify that as well. There's no brackets here to multiply out. So I have 6b minus b, that will give us 5b and plus the 5a. Okay, now if we look at this, we have a's first and b's afterwards, we have b first and a afterwards. Let's just change them around and make it like similar. So this is exactly the same as that. We just change the order of the plus one. Now, what we need to do first of all, if you look at this here, it's beginning to get to where we need it to be. I'm going to factorize the 5 out. I'm going to factorize the 2 out from here. So O to x is currently this, and O to y is currently that. Let's just check everything is in view. Oh, that's looking lovely. Right, the question says prove that O to x, this is equal to 2/5 of that. Right, so if we get O to y, where's O to y? Here's O to y. Lovely. And if you multiply O to y by 2/5, we should get O to x. So let's try that. We're going to multiply this by 2/5. And they're saying that when we multiply this vector, which is OY, by 2/5, we should get O to x. Well, O to x is over here. Let's see if that happens. So we need to show that if we get this O to y vector, which is here, and then we get all of this, we multiply by 2/5, O to y times by 2/5 should give us O to x. So this times by that should give us this. So let's see what happens. Now, the 5 and the 5 cancel each other out. And that leaves us behind with this one here, which is our O to x. So 2 is equal to 5, divide that by 5 is 1, divide that by 5 is 1. We're left with 2 brackets a plus b, and we have done it successfully. So we have proved that this, which is the O to x, is equal to the 2/5 of O to y, which, as you can see, the left and the right are equal to each other, and that is the end of that question.